Alright, so we are going to be looking at a formula for compound interest, and I really just want for me to be quiet for a minute and let you guys write down the formula and what all the variables stand for. So just take a minute to copy all this down. Alright, so let's talk through this. P is your principal. It's your amount that you start with. Either you're putting that amount into the bank or that's the amount of your loan. And it gets multiplied by 1 plus your interest rate. So your interest rate is going to be given as a percent, such as 2%. But in your formula, you're always going to convert that over into decimal form when you plug it in. Then we have N. N is the number of times per year that our interest is going to get compounded. And notice the letter N appears 2 different places in our formula. Now over here on the side I put M. In the dual credit textbook, they use M instead of N. So I just wanted to put that note in there. For those of you taking dual credit on the dual credit test, if you see a letter M instead of an N, it represents the same thing. Then T is your time in years. So you can see we have multiple variables in this equation. But notice in particular the letter T. The letter T is part of your exponent. So think about how exponential growth happens. So as your exponent becomes larger, things are going to get larger much faster, right? So this letter T, this time, plays a big role in things. If you are putting money in the bank, you want to look for an interest rate that is the highest that you can find. If you're getting a loan, you want an interest rate that is as low as you can find. So those are the things that you're looking at. Alright, so we're going to do an example problem. I know a few of you are still copying that, so I'm going to keep that right there. We'll go ahead and go slide a little bit up so I can fit this example. So here's our example. $14,900 is invested in a quarterly compounded account at 6%. So let's talk about what these different pieces of information mean. The $14,900, that's going to be your principal. So that's letter P. If it is quarterly compounded, quarterly means 4 times a year. So that means that your variable N is going to equal 4. If your At 6%, 6% then is your interest rate, and you're going to change that into the decimal, 0.06. So that's your scenario. That's the situation that you have. And with that pieces of information, we can answer some different questions. All right. So question A for us to answer is, how much is in the account after 2 years? So our 2 years right here, that is our time. So that's variable T. And they're asking us for how much is in the account. That's our letter A. So now we have all of our variables accounted for. So we are going to just go ahead and plug everything in. So we're going to have A. A is what we're looking for. A is what we're looking for. 14,900, that's our principal, our starting amount. 1 plus 0.06, because that's our interest rate, divided by 4, because it says quarterly compounded. And then our exponent is the product of 4 times 2. Once you have that written down, your calculator is going to do everything else. So go ahead and grab your calculator. Get to a good spot on the screen here. Alright, so we're going to type in 14,900 and then parentheses and then 1 plus, and I'm going to go ahead and insert a fraction. So alpha y equals is one way to get to your fraction. You might know another way, but alpha y equals, enter. And in my numerator I've got 0.06. In my denominator, I have 4. I'm going to arrow over and then close out those parentheses. And then that's going to be to the, and I'm going to go ahead and multiply 4 times 2 in my head and put 8. Now, before we press enter, let's talk about common sense. If you put $14,900 in the bank and you get interest, your answer should be more than what? More than 14,900. Whenever you're typing a lot of stuff in the calculator, you want to think of what's my reasonable answer, so that if you just mistype something and you get an answer that does not make sense, you know that it doesn't make sense, right? So we should be getting a number that is somewhat larger than 14,900. So when we press enter, and we get 16,784 point, and what should we round to? The hundreds, because it's money. So we're going to round to the nearest cent, and we're going to write down $16,784.74. So you may have heard the expression, money doesn't grow on trees. It's true. Money does grow in an interest-bearing account. And you may have heard the expression, the rich get richer. Yes, this is what happens. When you have money that you don't need to spend to live on, then you have the luxury of putting that money into an account, and that money gets interest. And so you're not working for that money. You're just sitting around passively. That money is just growing. If you don't have a chunk of money to start with, then you cannot participate in that life. So there are some bills in Congress about tax rates and so forth, and that's one of those things to think about. The laws that we have and the fact that taxes are meant to serve the public, and some people are at an advantage, and I've had arguments with people who are like, but those people worked for their money. No. They may have done some work, but they didn't work for all that money they had. They had the luxury of starting with a lot of money, and then they were able to gain interest. Right? So, just think about that. $14,900, you don't do anything except put it in the bank and leave it alone. 2 years later, you have almost $2,000 more. Now, provided that the inflation rate does not jump as highly as your interest rate, then you're in good shape. All right, we're going to take this same scenario and ask a different question.